Hello there. You're listening to Oyla, a science podcast for students. We tell stories that make you smarter. Don't forget to subscribe so you don't miss our latest episodes. You can discover even more about science and the world around us in our magazine, so head over to Oyla to check it out.
Have you heard the old folktale about Salt, the one with the king who chose the heir to his throne amongst his 3 daughters? Hello, friends, and welcome to Oyla Podcast. The king cared very deeply about the future of his kingdom and wanted to pass it on to the hands of his daughters. He decided to ask the princesses how much they loved their father. To the oldest daughter, the king was more precious than gold, and to the middle daughter, he was like a bride's bouquet. The youngest daughter, though, answered that he was more precious than salt. The king was angered by his youngest daughter's words. He threw her out, choosing to disown her, and struggled for many years to forgive her. Until one day, all of the salt throughout his kingdom ran out. After living for some time on tasteless food, the king remembered the words of his youngest daughter, and he understood how much she truly loved him. He admitted to himself that, without salt, he couldn't even swallow the lump in his throat. When his youngest daughter returned with a never-ending supply of salt, her father fully appreciated the power of her love for him and her wisdom, and on that very day, he declared her to be queen. In such folklore lies the wisdom of generations. Salt actually is much more precious than gold. Now, let's figure out why. The salt that we add to our food is composed mainly of sodium chloride. In nature, this compound is found in the form of mineral halite, the basis of so-called rock salt. It's made up of white or clear crystals which come in various shades, usually due to impurities. Clay makes rock salt turn brown, talc turns it gray, iron compounds create yellow, orange, pink, and even red rock salt. Although rock salt contains many other substances, such as iodides, sulfides, bromides, magnesium, potassium, and calcium compounds, the first thing that comes to mind when you hear the word salt is probably sodium chloride. Salt is one of the most widespread compounds on Earth. There's so much of it that humans don't even need to produce it synthetically. Salt can be found on the ground in the form of sediments, and the world's oceans are basically salt solutions. For every 1,000 ton of water, there are 35 ton of salt. It is exactly this high salt concentration in the oceans that has made seawater evaporation the most profitable method of salt production. Salt from the ocean can be transferred into the air in the form of aerosols. Think about how your skin feels salty at the beach, even without going in the water, and droplets of salt water can be found even in the highest layers of the atmosphere. Moreover, salt is a crucial element in the bodies of living organisms. You've probably seen videos in which an inanimate frog is injected with saline solution and then begins to move as its muscles twitch in reaction to the injected sodium. Or you may have heard of a person falling ill and being given a sodium chloride intravenous infusion. This is done for many reasons, the main being the vital role that sodium plays in our bodies. A sodium disbalance can affect the way our bodies absorb drugs administered via IV. In chemistry, salt is an ionic compound consisting of equal numbers of sodium ions and chloride ions. Sodium is in group 1 and period 3 of the periodic table, which means that it has 3 energy levels and 1 electron is present in its outer layer. This makes sodium a very reactive element that constantly strives to get rid of its only electron to achieve the perfect state. Chlorine also belongs to period 3, but to group 7, meaning it has 7 electrons in its outer layer and it lacks only 1 electron to complete its electron level. You've probably already figured out that these two elements are attracted to each other with extraordinary force, forming an ionic bond. As a result of this reaction, sodium becomes positively charged and chlorine is negatively charged. In aqueous solutions, sodium chloride is found in the form of sodium and chlorine ions, which determines its physical and chemical properties. For example, when exposed to sulfuric acid, hydrogen chloride is quickly released from a salt solution in the form of a colorless gas with a pungent odor. When silver nitrate is added to sodium chloride, the silver ions combine with the chloride ions to form a white deposit of silver chloride. In ordinary salt crystals, each sodium atom is surrounded by 6 chlorine atoms, and each chlorine atom is surrounded by 6 sodium atoms. Because of its love for water, salt with impurities, industrial salt, is used for winter road maintenance. Industrial salt dissolves ice, and since the freezing point of the resulting solution is lower than that of pure water, we get wet, ice-free roads and sidewalks. This method is effective, but it negatively impacts the quality of soil, water, and materials that are exposed to it. So, in some countries, road salt is replaced by sand, calcium chloride, or magnesium chloride. In addition to the ordinary salt crystals, scientists recently discovered forbidden salt. Under normal conditions, sodium and chloride atoms can only interact in a 1:1 ratio. Under pressure, though, the normal rules of chemistry no longer apply, and we can produce unusual structures. For us, the existence of salt in aqueous solutions in the form of ions is of great importance. After all, our lives are possible due to the properties of sodium ions in water. The human body is up to 60% water, and all of our nutritional processes take place in an aqueous medium. This is why every cell in our bodies is equipped with a sodium-potassium pump. Potassium is another metal that has only one electron on the outer level, but unlike sodium, which tries to bind to water ions, potassium removes water from the cell. These two elements are part of the cell membrane and, due to their contrasting properties, allow water to circulate in the body, thereby providing each cell with nutrients. Schematically, this can be depicted as follows. The inner layer of the membrane is made of potassium, while the sodium layer on the outside of the cell membrane attracts the water saturated with nutrients and allows it to penetrate the cell. As the levels of water and sodium ions in the cell elevate, potassium comes on the scene and ushers out the unwelcome guests, the water molecules and excessive sodium ions. Therefore, it is very important to maintain the optimal balance of sodium to potassium intake. To do so, some people avoid regular table salt and instead use salt with additives. For example, in addition to sodium, pink Himalayan salt contains potassium, calcium, and other minerals. Some people tend to oversalt their food, which leads to an oversaturation of sodium ions and a slow circulation of water in the body. But cutting out salt completely can be just as dangerous. Low sodium levels could inhibit normal cellular functions and transmission of nerve impulses. On average, most adults need less than 5 grams of salt per day. This amounts to approximately 4 pounds of salt every year. According to the World Health Organization, most people exceed this norm, consuming around 9 to 12 grams of salt per day. Today, salt is available to most people, but in the past, salt mining was not easy and the price of salt soared. At one time, salt even functioned as currency. You could buy goods and even pay your taxes with salt. Sometimes, taxes were introduced on the salt itself, since only the wealthy could afford to buy it. In many cultures, salt played an important role. In Slavic cultures, guests were traditionally welcomed with a loaf of bread and a cellar of salt. Roman salaries may once have been paid in salt. In India, there are traditions that involve using salt to ward off the evil eye. Fascinatingly, in some religions, salt and holy water are used to cast out demons. It's difficult to imagine how much salt was brought in for the filming of Supernatural's 11 seasons, since they sprinkled it in all their fights against ghosts and other evil spirits. We don't know how effective salt is in the battle against the otherworldly, but we do know that it's been used for a long time to fight bacteria. Since ancient times, nomads have preserved meat by coating it with salt. This method allowed for long-term storage of meat through the winter months. The ancient Egyptians were fond of salted fish, quail, and duck. Interestingly, salt doesn't just produce savory flavors. You may have seen someone add a pinch of salt while cooking not only soups or main courses, but also when baking desserts, and perhaps even making coffee. There is a chemical explanation for this. Salt decreases the water activity of foods, enhancing the intensity and concentration of flavors. This is why unsalted food seems not only tasteless but also odorless. And smell, as you may know if you've ever experienced anosmia, is crucial for a good appetite. Besides, salt stimulates the nerve endings on our tongues, making flavors even more intense. That's why a pinch of salt added to a cake doesn't give it a salty taste, but makes the sweetness even richer. So, apart from its nutritional value, salt also shapes our culture and history. Without it, we would be nowhere, and in this way, it really is more precious than gold. Just remember to practice moderation. Even with white gold, you can have too much of a good thing.
You've been listening to a podcast brought to you by Oyla, a science magazine for students. Please subscribe and check out our website, Oyla, for more information.